In this lesson, we will prove, step by step, that the fraction sine to the fourth theta minus cosine to the fourth theta over sine squared theta minus cosine squared theta is equal to 1. Our strategy will be to factor using the difference of squares, simplify, and then use the Pythagorean identity. Step 1. Recognize the difference of squares pattern. For any a and b, a squared minus b squared equals open parenthesis, a minus b close parenthesis times open parenthesis, a plus b close parenthesis. We will use this next. Step 2. Factor the numerator. Let it be sine squared theta and b be cosine squared theta. Then the numerator becomes open parenthesis sine squared theta minus cosine squared theta close parenthesis times open parenthesis sine squared theta plus cosine squared theta close parenthesis. Step 3. Substitute this factorization into the original fraction. Step 4. Cancel the common factor sine squared theta minus cosine squared theta, which appears in both numerator and denominator, provided it is not 0. After canceling, we are left with sine squared theta plus cosine squared theta. Step 5. Use the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Therefore, the original fraction simplifies to 1. Proof complete.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time only on MyVerse Maths.